Welcome to the video lesson for stretching and shrinking of functions. We're going to talk about how to vertically stretch and shrink, as well as how to horizontally stretch and shrink our functions. To begin with, for our vertical stretch, I want to point out that we have a scalar value on the outside of your function, so this is 2 times f of x. And when the number is on the outside and it is bigger than 1, we see that we're going to have a vertical stretch. And what we do to represent that is I'm essentially multiplying the whole function by 2, so I'm multiplying all my y values by 2. So I'm going to look at all my original y values, and I'm going to double them, and then I'm going to give them the same x value. So, for example, I have the point -4, +2. At this point here, my y value is a +2. If I multiply that by 2, then I get -4, +4. Again, we're just multiplying the y value by 2. For my next point at -2, 0, I can see that my y value is 0. 0 times 2 is not going to change. It's going to stay at 0. Moving on, I have another point here at 0, 2. Again, multiplying that y value by 2 because that's our scalar. We're going to see that we have a value of 4. And then last but not least, I have a point here at 2, 4. Again, multiplying my y value, which is a 4 by 2, gets me 8. And I now have my new function. If I connect my dots here, I can see that this has been vertically stretched. It is a little bit narrower, or you can say it's a little bit taller. Picture a rubber band. We're taking a rubber band and we're pulling it or stretching it, so it's getting taller and it's getting skinnier at the same time. If we compare that to our vertical shrink, I see I have a number on the outside, so now it's a vertical stretch or shrink. In this case, it's 1/2, so all my y values are going to be multiplied by 1/2, which will make them smaller. Looking at our values, again, I have a y value. All right, the point is -4, 2. Our y value of 2 gets multiplied by that 1/2. 2 times 1/2 is going to be 1. Our next point at -2, 0, again, that 0 is not going to change because 0 times anything is 0. And then we move over to find our next point here at 0, 2. I take my y value of 2, multiply it by this 1/2. 2 times 1/2 is going to be 1. And then for my last point, I have the point 2, 4. Again, we're going to take that value of 4, multiply it by 1/2, and I get 2. And I now have my new function. We can see, again, this function is a little bit flatter, or we can say that it's vertically shrunk. So to kind of recap here, if we look at our values here, notice that we have an a to represent the number on the outside. If the absolute value of a is greater than 1, we're going to have a vertical stretch. If the absolute value of a is between 0 and 1, instead we're going to have a vertical shrink. Now I say absolute value because occasionally our a value is negative, and that will have a stretch or shrink as well as a reflection across the x-axis. So we look at the absolute value to determine if it's going to be a stretch or a shrink. All right, let's go ahead and take a look at our horizontal changes. All right, just like vertically, we can have a horizontal stretch or a horizontal shrink, but notice that it's the opposite here. I have a 1/2 on the inside. That value is between 0 and 1, and that 1/2 is actually going to have a horizontal stretch, whereas this 2 is going to have a horizontal shrink. So it does the opposite of what the vertical stretches did. When your value is between 0 and 1, you're going to have a stretch. If your value is greater than 1, you're going to have a shrink. Let's go ahead and look at how we can apply this. I'm going to go ahead and take our first point here, which is this -4, 2. I'm going to go ahead and write that down there. And we're going to focus specifically on the x value. I know that that is a specific x value for our function. And what I'm going to do is take my expression, this 1/2 x, and I'm going to set that equal to my -4. And we're going to solve for x here to see what the actual stretch will look like. To solve for x, I'm going to be multiplying both sides by 2. And I can see that now my x value is actually going to be -8. So it was at -4, but because I had a value of 1/2, I see it stretched to be at -8. My y value stays the same though in this case, so I'm going to have a point at -8, 2. So essentially we are doubling all of our x values. If we look at my next point, we have the point -2, 0. Again, I'm doubling my x value, so that -2 is going to become a -4. Again, the y value is unchanged. And look at my next point here, we have 0, 2. Doubling 0 is not going to change it at all. Oops, sorry, it's going to stay at 0, 2. And then the last point we have is the 0.24. Again, we are doubling our x value as you demonstrated in our example up here. So if I multiply that 2 by 2, we get 4. Again, the y value is going to stay unchanged. And we have, again, a horizontal stretch here. We can see that it's definitely going to be wider than the original function. If we look at our next example, we have f of 2x. Again, our value in here is 2. So what we're going to do, the same thing we did for our last example, I'm going to take my first point here, which is negative 4, 2, and I'm looking only at the x value, this negative 4. I'm going to set my expression 2x equal to negative 4 to see exactly what happens to it. If I divide both sides by 2 to solve for x, I get that my new x value is actually going to be negative 2. So unlike the previous example, because our our b value was 2 here, we're actually dividing our x values by it. We're cutting them in half. So I'm going to do that to all of my values. I know the y value, again, is going to stay unchanged. So we have, instead of negative 4, we have negative 2 and 2. When I look at my next point, this is negative 2, 0. I'm going to divide negative 2 by 2, divide it in half, and we get negative 1, 0. Our 0, 2 is going to remain unchanged because dividing 0 by 2 does not move it. And then we have this 2, 4. Again, dividing our x value by 2, cutting in half is going to give us a 0.14. Again, important to note that your x values changed, but your y values did not because we had a b value here. This does look similar to a vertical stretch. The difference here, you can see that your y values were not changed. It's just compressed horizontally or skinnier horizontally. It's not taller at all. Whereas if we look at the vertical stretch, we can see that it was taller, but not really wider or skinnier, just definitely taller. All right, if we wanted to go ahead and generalize here, just like we did for our vertical stretch, this is for our b value. So if b is between 0 and 1, then we know that we're going to have a stretch. If b is greater than 1, then we're going to have a shrink. And these are horizontal or vertical shrinks. And just so you guys are clear, when I'm referencing my a and my b values, I'm looking at my original notation here, where a is a number on the outside, and b is a number that's being multiplied by that x value. Okay, so here we're going to have a combination of transformations, and I'm going to go from left to right. To begin with, I see that I have a negative 1/2. That negative sign is going to do something very specific here. Again, so this negative 1/2 is going to give us a reflection across the x-axis. In addition, if I look at that absolute value of 1/2, which I'm going to write down here at the bottom, I see that I have a positive 1/2. Going back to our vertical changes here, this is going to be a vertical shrink. So I'm going to reflect it across my x-axis, and then I have a vertical shrink. And then finally, I have this +1. That'll be the second thing I'm going to apply. And we're going to have a shift of up 1. All right, let's go ahead and try and apply that. Again, I'm going to do my reflection first, and then my shrink, and then my shift. So I'm going to do this in steps. You guys can do this in less than the 3 steps I'm going to do, but I just want to make sure that I'm clear about what I'm doing. So when I reflect this across the x-axis, I am going to basically make all my y values the opposite. So a positive 2 is going to become a negative 2. The 0 is going to stay 0, and then this positive 2 again is going to become a negative 2, and then this positive 4 becomes a negative 4. So this is my reflection because of the negative sign. And then the 1/2 is going to cause a shrink. So I'm again multiplying all of my y values by 1/2. I'm going to have a negative 1. Again, 0 doesn't change. A negative 1, and then a negative 2. And then the last thing we're going to do is we're going to shift all of our values up 1 because of the +1. So then this green shape is going to be our final answer. Again, the process here, we did our reflection first. That is always your first step. And then we had our vertical shrink. And then finally, we had our vertical shift up. So we're going to apply that again. We have our reflections first. Then we have vertical stretch or shrink. And then we're going to have our horizontal stretch or shrink if possible. And lastly, our transformations left, right, up, or down. Go ahead and try and do example 2, but I'm going to give you a little bit of a starter here. I know our notation is specific, but I would definitely think about distributing this 1/2. to get a little more of an accurate understanding of what's happening. And then go ahead and see if you guys can graph it, and then check back in with me to see what the answer is. All right, so I try to kind of color code what was happening here. I did rewrite the function as negative f of 1/2 x plus 1, so it again can get that accurate representation of what's happening. I first reflected the function across the x-axis because of the negative sign, and then because of the 1/2, I took everything and I had a horizontal stretch of 2, because again, that 1/2 has the opposite effect, so you can see it's now going to be wider. After I did that, I shifted everything to the left 1 because we had that plus 1. And then finally, that green shape being my final answer, everything got moved up 3. All right, that does it for our notes on shrinking and stretching. Go ahead and attempt the homework, and good luck.